ROS MCP, Bridging Robotics and AI Agents. A comprehensive technical deep dive into the universal protocol connecting robot operating system with large language model agents. July 2026. Our agenda covers 13 sections, from foundations and core functions, through installation and configuration, to cross-agent compatibility, deployment strategies, and strategic takeaways. Part 1, Foundations. What is ROS MCP and why does it matter? ROS MCP builds on two foundational technologies: ROS, the robot operating system, a universal software framework managing hardware drivers and motion control, and MCP, the model control protocol, a standardized tool calling interface for AI agents. ROS MCP is a middleware adaptation layer that bridges ROS robot systems with LLM agents. Its core value: protocol translation, standardized toolset, lightweight edge deployment, and complete agent-agnostic design. Part 2, the three core functions of ROS MCP. Pillar 1 is bidirectional protocol translation. AI agents issue MCP commands which ROS MCP converts to ROS messages controlling robot arms, vehicles, and navigation. Sensor data flows back through the same pipeline to the LLM. Pillars 2 and 3, standardized robot toolset, making every ROS function an AI callable tool, and lightweight edge deployment, running on device with 7B models for millisecond latency. Real-world applications include humanoid robots, autonomous ground vehicles, and robotic arm workstations, all controlled through natural language via ROS MCP. Part 3, Installation Architecture. ROS MCP is never bundled with ROS 2. It must be independently installed. ROS MCP is a community third-party tool, not an official ROS package. It requires separate installation via git clone in UV, npm, or Docker. 3 installation methods: Python UV with git clone, Node.js via npm, or Docker container. ROS MCP is fully isolated from ROS 2 installations. Part 4, AI Client Configuration Guide for Claude Desktop and Cursor. The MCP.json configuration requires absolute paths, ROS bridge WebSocket URL, timeout settings, and auto-approval lists for trusted tools. 2 communication architectures: STIO subprocess mode for local development, and HTTPS-SE remote service for multi-client production deployments. Part 5, CLI and headless deployment on Ubuntu 22.04 without any GUI. For deployment paths for headless systems, HTTP background service, MCP CLI terminal tool, Aluma CLI integration, and custom Python scripts. Part 6, Cross-Agent Universal Compatibility. ROS MCP is agent-agnostic by design. The 3-layer decoupled architecture means ROS MCP code requires zero modification when switching between Claude, Cursor, Codex, Hermes, or any MCP-compatible agent. Part 7, ROS 2 in the AI era. Is it obsolete or essential? ROS 2 is not obsolete. It is the mandatory foundation. AI is the brain, ROS 2 is the nervous system. LLMs cannot replace real-time hardware control, hardware driver ecosystems, or deterministic engineering. Part 8, Why the autonomous driving end-to-end pattern will not replicate in robotics. Autonomous driving has low-dimensional action space and soft contact. Robotics has dimensional explosion, rigid physical interaction with zero tolerance, and open-ended complex tasks requiring ROS 2 layered architecture. Part 9, General versus Specialized Robot AI Agents. General agents like Hermes and Claude Code serve development and education. Specialized agents like ROS Claw serve industrial production with built-in safety and multi-robot coordination. Part 10, Open Source Landscape and World Model Architecture. ROS Claw and ROS LLM are fully open source with MIT and Apache licenses. World models are independent services decoupled from robot agents, deployable as separate GPU inference processes. Cloud versus Edge model deployment: Pure Cloud for prototyping, Pure Edge for production robots, and Edge Cloud hybrid as the pragmatic compromise for most commercial teams. Part 12, Strategic Summary and Key Takeaways. 8 Key Takeaways. ROS MCP is Universal Bridge, ROS2 is AI Era Foundation, your existing ROS2 knowledge gaining premium value, and AI enhancing rather than replacing robotics. Thank you for your attention. ROS MCP, one protocol, all agents, every robot. Questions and discussion welcome.